When I was asked by Teachers TV to teach a pair of maths masterclasses, I decided to tackle two topics that can be both tricky to teach and that students don't always see the wider point of. They're both topics that it's possible to have a lot of fun with, and I'm hoping that's what this group of Year 10 students from 3 North London schools will think too. OK, we're all good at numbers, aren't we? Yeah? Numbers are great. We use them every day. We use them in school. We use them in real life. Do we all feel comfortable with numbers? Yeah. Do we all feel comfortable with algebra?
Did I hear the word algebra? Nasty, scary, X's and Y's. Be afraid. Be very afraid.
Be afraid? Be very afraid. Do you agree, Krishnan? Definitely not. Algebra can be fantastic. Now, we'll move on, first of all, to a little number trick. Think about your birthdays. Write down on your clipboard your month number. So if you were born in September, you can write down a 9. If you're born in December, write down 12. And we're going to multiply it by 5. OK? Multiply your month number by 5. Write down a running total as you go along. Then, add 7. All done that? Easy? Right. Times by 4. Multiply by 4, so that's easy. Double it. And then double it again. OK. Unlucky for some, not for me. Add 13. Got a running total. Now, we're going to multiply by 5 again. Your number's getting quite big now. That's easy, isn't it? Times by 10 and halve it. Last step. I want you to add your day number. If you were born on the 25th of December, your day number's 25. Doesn't matter what month it is. If you were born on the 6th of June, your day number's 6. Hands up who's got a number. Lovely. Mohammed, what did you get?
1110.
You must be one of the oldest people in your year group.
Probably.
September the 5th?
Yeah.
Oh, wow. What about you, Amy?
717.
717, May the 12th. Excellent. OK. I'm right, Anna. You were shocked then, weren't you? It always works. Raheel?
606.
606. OK, you were born on April Fool's Day.
Yeah.
Fantastic! How did I do that? How did I do that? I bet you really want to know, don't you? Yeah. Do you really, really want to know? Yeah. We can use algebra to work out how I did that. And never mind this devil's work. It's not devil's work at all. It's just thinking about things and numbers in a clear way. In fact, algebra is fantastic, OK? What is algebra all about? What is maths all about? Is it about flat caps? OK, look at my market stall. Is maths about fruit? Is maths about numbers? Let's have a look. This is Johnny's market stall. Look at this beautiful collection of stuff. What have we got on here, Raheel? Well, we've got beautiful oranges from Spain. We've got lovely apples from England. What about these, Edward? You like some bananas? Beautiful. All the way from the West Indies. And the most appealing of all, look what we've got here. What have we got? Numbers. Ah, a prime number. I love it. 3. And it's triangular. I love it. What I'd like to do is to come up and select either one of the fruits, I don't mind which one, orange, apple or banana, or choose one number or one fruit, not both. OK, so up you come, put your clipboards down, and come to my market stall. Don't be shy. Everything's going cheap. Excellent. So we've all got either a fruit or a number. So, who went for a number? Hold them up. Not many numbers there, is there? And who went for a fruit? Who's gone for a banana? Beautiful. Like bananas. Excellent. OK. Look at what you've got in your hand. Double it. Keep it in your head. Right. Now add 8. Add 8. Got that? Now we're going to halve what you've got in your head. Halve it. OK. Now, take away what you picked off the stall. Take away what you started with. Could you, Arnold, could you come over here? So the people who chose numbers come over here, and the people who chose fruits make way for them and sit together over this side, OK? So let's see how many numbers we've got. We've actually got 1, 2, 3. We've only got 4. Right then, what did you end up with, Anton? 4. Quadro?
4.
4. Arnold?
4.
OK, you all ended in 4. OK, if we started with 100, what do you think it's going to end in? If we start with 1,000,000? 4. See, it's always going to end in 4.
How come?
Can you prove it? If we tried 1,000,000 numbers, would that prove it?
Probably, yeah.
If we spent our... Probably, yeah. Why?
Because
You've tried 1,000,000 and you haven't found one that's gone wrong. Sorry, you haven't proved it. If you spent all your life, I'd love to do this, testing every number, I reckon I could get through 7 million before I'm 70. I worked that out. Yeah? 7 million. Would it prove it?
No.
Got a problem. Look at all these fruits. What did you end up with?
4.
You ended up with 4?
Yes.
4.
4?
4.
4? 4? Do you understand why it ended in 4, Adam?
No.
You don't understand. You just guessed, didn't you? You copied them, didn't you?
No.
You did copy him. Adam, come on up. Give him a round of applause. He's going to come and help me. He's the man with the orange. Because he doesn't know what's going on, does he? That's what he started with. He started with an orange. Looks juicy. What did we do? Double it. Right.
Yeah.
Now you got 2, 1 in each hand. Marvellous. What's he got?
2.
Louder. 2. What did we do next? We added 8. Right. Oh, lovely. We added 8. What have you got now? Yeah. Put your oranges together. Can you hold 2 oranges together? Bit tricky. Now he's got 2 oranges plus 8. OK. Next step. Oh, it was halve it, wasn't it?
Yeah.
This is an important step. How are we going to halve what he's got in his hand? Any ideas?
you put an orange down and you take the 8 and replace it with a 4.
Right, so you halve that hand and you halve that number
Yes.
and you treat them separately because one's fruit and one's numbers. I like it. Replace it with a 4. I like it. Last step. Take away what you started with. Take away what you started with?
Orange.
I've just taken away his orange. OK, so hang on a minute. He started with an orange and he got 4. OK? You started, Mikhail, with a banana. What do you think you ended up with?
4.
Of course you would. Could you prove it now?
Yeah.
We've just demonstrated, OK, that whatever you start with, whether it's an apple, a banana, or even an orange, these could be any fruits, these could be any numbers. You will always, always end in 4. So that's proof. That's better than trying loads of just numbers and hoping for the best, because the one might come along and it might say, no, it don't work after all. This has proved it's always going to end in 4. That's magic, and that is algebra. Now then, let's just have a think about this. Oh, can you help me with my coat, Adam? It's a bit tight, actually, that. God, they never got it fitted properly after all. Right, we've got an orange and a 4. The penultimate step, yeah? You've got your orange and your 4. And what we did, of course, we took away the orange. It's completely separate to the 4. So we always keep letters or variables, don't we, in algebra, and numbers separately, OK? Separate to each other. They don't mix up. Now, let's just demonstrate this little idea, OK? Could you sit down? Thanks, Adam. Give him a round of applause. Excellent. OK. Now then, who likes cooking? Come on, volunteers. Who likes cooking? Mohammed, come on up. Come on up. You like cookery?
Yeah.
Brilliant. Excellent. OK, you got your orange. Excellent. Right, well, I'm going to swap your orange for a boring number. Stick it in my cookery bowl. Go on, stick it in and mix it up. Mix it up. Give it a good mix. OK, so we start with a nice bit of raw 4. Nice one. We'll just add a few more numbers. Stick them in. Right, come on. And a few more numbers. Excellent. Mix it all in. OK, what number did you start with that I just gave you?
4.
Was it 4? Pick it out then. Which one was it? You can find it. Is that the 4? Are you sure? There's another pink 4 in there, though. Was it that one?
No, that one.
How do you know?
I'm not sure.
You're not sure?
Yeah.
OK. Why is he not sure? Hands up.
Same number.
It's the same number. All right. Why is it so difficult to find? Who chose a banana? Krishnan. Come on up. Thank you very much, Mohammed. You just sit down. Krishnan. You actually chose a fruit. Get that in the mixing bowl. Go on. Stick it in.
I want to eat it.
Stick it in. I know you want to eat it. OK, but I want you to mix it in first, yeah? To get it all mixed in nicely. Come on. Beautiful. Get that banana mixed up. Bit more vigorous. Come on. Now then, for a banana flavour, we need a few more numbers. Blue's my favourite colour, so I'll have a blue 6 as well. Get it in. Right, mix it up. Close your eyes. Right. Put your hand in and and pick out what you started with. You're looking. How's he done that? How's he done that? Round of applause! Magic. Go on, you can have that banana. Don't have another one. How did he do that? How did he do that? Ado, how did he do it?
It was one banana in the bowl.
It was what?
One banana.
It was one banana. But how did he pick it out so easily?
Because bananas and numbers are different.
They don't mix, do they? Obvious. So whatever we start with, whether it's an orange, an apple, a banana, what have I got in here? A bank card, but I'm not going to give you that to start with, am I? Hey? Whether it's N, it could be anything. Get it? Anything. It could be anything. N stands for any number. These fruits stand for any number. Now we can feel the power of algebra. Can you feel it? Yeah. Can you feel it? Yeah. Can you feel it? Yeah. Oh, yeah. Now that we're grown up, we're not scared of this N anymore. It's beautiful. Do you want to touch it? It's nice, isn't it? Yeah?
Yes.
Yeah, feel it? It could stand for anything, yeah? Put your hands on it, lay your hands on the N. It could be any letter. N for number? Sounds good. Right. 3 consecutive numbers.
1, 2, 3.
That'll do. 1, 2, 3, I like it. You know what consecutive means, don't you?
One after the other.
One number following on after the other. Easy. So, shout out the mean. Shout out the mean to me
2.
of those numbers. 2. Why do you think it's 2?
Because you have to add them together and divide by how many numbers you...
Ah, right, to work out the mean, you have to add them together, which is 6, of course. OK, and divide by 3. Why 3? 3 numbers, of course, so we get the answer of? OK, what's the median of 1, 2 and 3?
2.
What's the median?
2.
What does the median mean? I'll just throw that in.
Middle.
Oh, the middle number when they're all in order. They are already in order. OK? So the median is equal to 2 as well. Is that obvious? Median equals 2. So give me another set of higher consecutive numbers, Edward.
7, 8, 9.
Yeah, all right, a bit bigger. 7, 8, 9. It's obvious, isn't it? So shout out the mean to me. Come on, add them up.
8.
It's going to be 8, yeah? 7 and 8 and 9 divided by 3 is 8. What's the median? Ado. Why?
Is in the middle.
OK, this is always going to work, isn't it? The mean is equal to the median. This is always going to work, isn't it? For any 3 consecutive numbers, isn't it? Yeah. Prove it. Prove it. Prove it. You got a pen, you got your N. So we can begin to do it, can't we? Write down 3 consecutive numbers. I'll give you a clue. Your first consecutive number is that. Write down N. Right, write down the next 2 consecutive numbers. You can put them in a line if you want. So you can start with N. You can write them underneath if you want. What number follows N? In other words, what's one more? Arnold.
N plus 1.
Easy. OK. And then the one after that. Alex, have you got the one after that?
N plus 2.
It's easy. Add them up. N plus 1 and N plus 2. Remember, letters, variables, and numbers don't mix. So when we're collecting these up, we count our N's off, and we count our numbers off separately, and we have a final expression of...
3n plus 3.
So the mean is 3n plus 3, yeah?
Yeah. No. 7 divided by 3.
Oh, we're going to divide by 3 as well, yeah. 3n plus 3. Yeah, the mean equals 3n plus 3 divided by 3, keeping your letters and your numbers separately. We've got to divide the 3n by 3 and the 3 by 3. What do we get with, Dahlia?
N plus 1.
We get n plus 1.